Alain, merci beaucoup. I think it was very important to understand from EDF, such a gigantic organization for energy production, their forecast and therefore the flexibility linked to the alternate generation of energy, and also how it will expect it to evolve. So that the problems are going to grow. They're not going to, if we do not act properly. So if we do not start, as he said already, with some remediation, how to cope with this, let's say, variability with this flexibility. So also thank you for the stimulating final part of your speech where you already gave some possible remediation, some possible strategy, including storage, including the smart grids, including the market. And I think we will come back again to this point. So now I'm very curious to look at, to hear the other point of view, the TSO, because you have to cope with this kind of continuous flexibility and variability of the energy source, and to accommodate to the energy demand. So I really like to ask Inge, how do they plan ahead from the TSO point of view for this kind of intelligent future development of the transmission system? Thank you, Inge.
Okay, good afternoon. First of all, thank you very much for giving me this opportunity to talk and contribute to this panel debate about optimizing the energy system. It's a pleasure for me just to give a brief overview of our approach to develop the energy system in Denmark, and particularly seen from a view of a TSO. We see the integration of energy systems as a mean and the most important mean to ensure the conversion of the energy system to a fossil-free future in an energy-efficient and competitive way. I come from the Danish TSO, Energinet.dk, and we are responsible for both the gas and electricity systems. And we also have the task of ensuring competitive and efficient electricity and gas markets. This task is unusual for a TSO, but we have it in Denmark. We own 6,800 kilometers of electricity transmission lines, and we have 924 kilometers of gas pipeline, and we are approximately 680 employees. This means that on a European scale, we are a very small TSO, though we are situated in a very central position in the energy system in Europe. Being TSO for both electricity and gas allows us to be more holistic in our approach of planning the grids. We are not at that stage yet where we have an integrated and common planning of the grids, but we have done some analysis of the future energy system that allows us to identify which technologies that we have to give priority. The energy system is changing, that's the fact. Both in Denmark and in the rest of Europe, there are ambitious goals of the amounts of renewables in the energy system. In Denmark, there's a goal of being fossil-free in 2050, but already in 2035, the electricity system and heating sectors has to be fossil-free. At present, there is 32% wind production in the electricity system, and already by 2020, this number has to be 50%. And fulfilling these national Danish goals also makes us fulfill the European goals on energy and climate, which are very ambitious too. We have analyzed different scenarios for the composition of the future energy system. The most likely scenario is a wind scenario, and this slide shows how the wind will constitute a higher and higher part of the electricity production towards 2050. Along with the wind production, we calculate that also gas from the renewables, PV, wave power, and biomass is going to contribute. The challenge here is that almost 90% of this production is going to be fluctuating. And to deal with this, we need a close integration with the rest of the energy system and with the neighboring systems as well. We see different means to deal with this challenge, depending on the time horizon. This slide shows two arrows. The upper arrow summarizes the technologies and means to balance the electricity system in short-term, medium-term, and long-term. The lower arrow summarizes the technologies and means to integrate renewables in other energy networks. And in short term, we see interconnectors, strengthening of the electricity grid, and flexible production in the market for the balancing, and for the integration in other energy systems, we see heat pumps and immersion heaters. In the medium term, we see an increased contribution from smart grids and flexible production and consumption for the balancing, and more heat pumps and electric vehicles for the integration in other energy systems. And in the final long term, we see balancing issues solved by electricity storage in gas, air, and batteries, whereas the integration in other energy systems is expected to be solved by use of hydrogen from electrolysis in the transport and gas sectors. The complete energy system we expect to look like this. It's a very complicated, though informative illustration that shows all the energy sources on the left-hand side and all the energy services on the right-hand side. In between, we have the different energy grids, such as electricity, heat, and gas, and the key technologies that has to act as link between these grids. And these constitute different kinds of conversion technologies. Again, what interests us is electricity and gas systems, though we cannot look apart from the rest of the energy system, just making sub-optimization of just electricity and gas grids. Therefore, we have a high interest in facilitating development of the conversion technologies such as power to gas and gas to power, like electrolysis, gasification, and gas storages. Some of these conversion technologies has a high temperature heat as a byproduct, and analysis shows that it's essential that this high temperature heat is not just used in district heating, but is used for industrial purposes or used to increase the efficiency of other conversion technologies. So the principles for designing the system should be that the cost for peak load and balancing and ancillary services should be reduced, preferably by market solutions. The electricity grids should be exploited as much as possible by finding alternative operation criteria, alternative to the N-1 criteria. Renewable electricity and biomass should be efficiently used in the production of fuels, and the system should be closely integrated across the energy carriers. And a very important point is that the system should be robust. This means that the energy services should be available when they are needed and asked for, and the price for the energy services should be as much as possible decoupled from the price of the primary energy sources. In a fossil fuel system, prices on the fuels will directly influence the prices of the energy service. This should be avoided in a future system by making a close integration and by having storages in the system. And this robustness and price invariance is a precondition in making the conversion of the energy system in an efficient and competitive way. So the important messages that we get from our analysis and that you should take from here is that improved energy efficiency is essential and must be kept in focus. Electrification of transport and heat is needed in order to reduce the need for fossil fuels. Flexible consumption, international market integration, and interconnectors reduce the need for thermal peak power production. The gas system and renewable gases is important means to ensure the security of supply and integration of biomass and fluctuating renewables. High temperature heat from the conversion processes should be integrated efficiently in a high energy in the energy system. And finally, robust market solutions and efficient information infrastructures is a precondition in this future system. And to realize this system, of course, a lot of R&D efforts are needed. In this illustration, some of the central conversion technologies have been plotted with the efficiency as a function of their technological maturity. That is, technologies at the upper left corner are those promising ones that really needs an R&D effort. For example, high temperature power to gas is still very immature, but it's very promising, and therefore an R&D effort would be needed here. On the other hand, technologies in the lower right corner are known and mature technologies that can be implemented today as they are, though they are not very promising for the future since their efficiency is relatively low. So to carry out these R&D efforts and to make the integration of energy systems needed using the connecting technologies, we need to cooperate. We need to make cooperation in projects across the borders of the member states and to develop common solutions. We already do cooperate to a wide extent, but we cooperate on technology level and not so much on system level, and this will be needed. And the tools is already in place. We have the integrated roadmap to guide us on the possibilities, and we have the possibility of getting funding through the Horizon 2020, through Energinet and national funding programs. So it is really just a matter of getting started, because we all need these solutions for the future. Thank you.
Again, thank you very much, Inge, also being directly to the point and respecting the time, and for the very challenging message you brought to us. Because again, this challenging system will be successful, will be lesson learned for Europe. So we count very much also from your support to the next step for the action plan, because it's very clear that Denmark can play an important role how to really implement from the very beginning, concrete action in implementing this kind of advanced integrated system. So I think that what you propose here is not only challenging for Denmark, but I think it's challenging for Europe. And again, also your final statement that the Horizon 2020 and let's say the roadmap is a clear stimulating tool, I think is very, let's say, consented by me and by most of the people here. So thank you very much. Now, after having heard Energinet and EDF, now I would like to go to RSE Italy. Michele de Nigris is the key expert in all the technologies linked to transmission and distribution, so I'm very eager to listen to him now and telling us from the research point of view, how do they see now the challenge ahead of us, and now that they think we need to focus our research activity to develop again this intelligent future electricity system. Thank you.
Thank you, Giovanni. Good morning, everybody, and thank you for inviting me here. The ones who had the possibility to participate in the gala dinner yesterday had also the possibility to listen and to appreciate energy in music in the city of Naples. But, you know, energy is not only in the music and in the city of Naples, in the very sunny city of Naples. Energy is also in the very foggy city of Milano, where RSE is located, and where we try to carry out research and system research on the energy system, linking the excellence of energy in Italy with the rest of Europe, leveraging the different competencies and the networking with the major stakeholders and with the industry. So in preparing this presentation, I said, well, am I going to speak about results of research? I ended up with 180 slides, so I said, perhaps I will more focus about roles and about what research can give to this integrated analysis. So, you may think that optimizing the energy system is something quite easy. In fact, You just have to well balance supply, conversion, transport of energy, and its final use. This can be achieved through planning beforehand, operation, monitoring, control, and of course, use of information. That's an art. It's not only science. In fact, smart grids are a very good initial example of how optimization can really be carried out. First of all, because they are cross-sectoral by definition. So networks need to deal and to balance the, I would say, interests of the different parties connected through the networks themselves. The other thing is that networks are the enabling technology for all the rest. So without networks, you will have no integration of renewables, no energy efficiency measures, and essentially no optimization of the system. Enlarging the picture, you go from electricity networks to energy networks. So linking electricity with other energy carriers. And you need then to understand transversal scenarios. You need to set up methods for a coordinated planning and try to find synergies and complementarities. And this is where the role of research centers can become quite important. Coming back to the smart grids, during a project, a coordination project that has just ended a few days ago that is called Grid Plus, we made a review of the goals and of the achievement, the level of achievement of the goals of the electricity grid initiative roadmap. This was done for transmission and for distribution to try to understand where there is a gap to be filled in terms of research, demonstration, and deployment. These are the main results as far as the transmission system is concerned in terms of the main drivers of the activity, and you see that much needs to be done in terms of market and asset management. Take into consideration the fact that these are average indicators out of 8 specific indicators for each of these points. Looking at the distribution part, we see that the situation is also very, very different and quite challenging. Here we need to carry out research on operation, planning, asset management, taking into consideration the presence of distributed generation and market with the new roles of the distribution system operator. So you will say nothing has been done? No, that's not correct. If you look at the distribution part and you look a little bit more in detail about the different functional objectives of the electricity grid initiative, and you look at the results of what is available in terms of hardware, you see that red is research, green is deployment and market uptake. You see that hardware is nearly already there, but there is a lot of activity to be carried out still in the field of software and in the field of ICT and intelligence. So going from the smart grids to the overall system optimization, and if we look at the priorities of the roadmap to try to see where do we need to optimize, we can see 4 main pillars. The first one is a new concept of grid. We have to integrate DG, we have to monitor the grid, we have to remote control the network, and to integrate the network with other energy means. A major role of storage. And here we have research on materials, concepts, interfaces, standards, and we need to demonstrate the results. We need to have a higher level of flexibility through two main assets: demand response on one hand and flexible generation on the other hand. And we have seen also from the previous speakers some solutions on these aspects. Smart cities is the fourth pillar of energy optimization in the integrated roadmap. And here we have planning of urban context, link between the different infrastructures, data hubs, so the importance of the information. And now, what is the role of research in addressing these four pillars? Well, if you imagine the research guy there and looking at the first aspect, the first pillar, so the grid concept, the researcher needs to collaborate with network operators, of course going beyond the state of the art, finding out new methods in terms of planning and so on, sensors, local intelligence, so also very much technology. Going up to storage, the researcher needs to collaborate with technology providers to validate the proposed solution, investigate new working paths, and look at cross-technologies in terms of use of storage, not only on the electricity network, but on a wider view. On the flexibility, we need to collaborate with regulators also. So this is increasing. I mean, of course, all the other stakeholders are always present in these, the more we go up. So we need to evaluate business models. We need to evaluate what are the benefits of the different solutions, and we need to consider all the options. In smart cities, we need to collaborate with public authorities as well to try to understand what are the involvement possible with the general public. So this is a big challenge. You see that the energy system as a whole is potentially very complex, and why research centers and research activity is so important. First of all, because each sector would optimize and would look internally, would look for an internal optimization of networks, electricity networks, gas networks, water networks, and so on, while a wider multidisciplinary activity, research activity, would try to look at the holistic approach. What does that mean in terms of what are the tools that are needed for this holistic approach? The first one is really the capability of setting up scenarios. Scenarios that take into consideration the entire electricity system. So electricity, heating, cooling, transport, taking into consideration end-use technologies, generation technologies, regulation, incentives, and so on, and try to look at strengths and weaknesses to help policy making and the energy strategy. The second aspect is methods, architectures, and standards. Here, the, sorry, is this the right one? Yeah, should be, yeah. Here we have to look at interoperability. We have to look at the use of conceptual models that are well developed for smart grid, and we need to accelerate standards to shorten, time to market. Good, here we are. No, I'm not finished. So, the other aspect is scaling up and replication and cost-benefit analysis. Present innovation is based on demonstrators. If your demonstrators are not scaled up or and replicated, the activity that you are demonstrating is really of very little value. So you need to address these aspects of rules, of scaling up and replication, and the cost-benefit analysis, which must be carried out looking at the correct boundaries. And here, I must say that what is important is the accessibility to data. Arrivo, ho finito. Last but not least is collaboration, cross-sectoral collaboration, which is essentially possible for the research centers. And this is the conclusions. So, research community is a key player in the implementation of the integrated roadmap. In addition to the specific capacity of technological development and validation, research communities offer a fresh, non-biased and overarching look at the entire energy system, and this must be valued in all instances as well as in Horizon 2020. And this is it. Thank you.